Hi, my name is Manjunath. Today I'll walk you through the 8051 microcontroller, an introductory session. So on the screen you see the 40-pin device of 8051. So it contains four ports: port 0, port 1, port 2, and port 3. And port 0 and port 2 also acts as a address signals, which is used when you are interfacing to the external memory, which could be either RAM or flash or EEPROM memory. The port 0 acts as a multiplexed address and data bus. So when the ALE signal is active, the values on this port will be address, and in the remaining period the values on this port will be the data. Okay, and port 1 is dedicated GPIO. Port 3 has a multiplexed functions or alternate functions. So it can be used as a GPIO, or it can be used for one of the alternate functions. For example, port 3.0, 3.1 are used for UART, and port 3.2, 3.3 serves the two interrupt inputs, and 3.4, 3.5 is used for timer inputs if you want to count the external events, and 3.6 and 3.7 are the control signals for read and write control signals when external memory is used. On the right hand side, on pin 31 you have the EA bar, that is the external address signal that is pulled to low to indicate that external memory is being used. And AL is the address latch enable, which goes active when address is placed on port 0, and the remaining time it will be inactive when the data is placed on those ports. Okay. Program store enable is used in conjunction with the RD bar when you want to use the external RAM for both data as well as the code. Okay. Now let's go through the functional block diagram of 8051. So this is the functional block diagram. So internally there are various blocks and which are interconnected to the system bus, or we can call it as an internal data bus. So where I am pointing my arrow, so this is the internal data bus. Okay, so let's start with the ALU. So this is an 8-bit microcontroller, so ALU is also 8-bit. That means it accepts the input in 8-bit length, and it produces the output in 8-bit. So it also processes all data in 8-bit granularity. So the input operands to the ALU is stored in the temp1 and temp2 registers. So data could be, the operands could be from anywhere. It could be from the RAM, which also contains the register space of the 8051. It could come from accumulator, it could come from the B register, or it could come from the port, which is also connected to the internal data bus, and it can also come from the ROM, for example the cons data which is stored in the that one. So all comes through from these different places. The data first has to be brought into these temp registers before executing. Okay. So on the left hand side you have this timing and control unit. So this has the instruction register. So it the instruction which is read okay, from the ROM is decoded, and it selects one of the operations of the ALU based on the opcode. Okay. So once that instruction is executed, it places the result on the data bus. So destination could be anywhere. So it could be in RAM, or in the accumulator, or in the B register. So any status, any arithmetic operation that will affect this carry flag, auxiliary carry flag, and overflow flag, it will be captured within this PSW, program status word. On the right hand side we have a set of blocks. One is the program address register, buffer, program counter incrementer, program counter, and data pointer register. Data pointer register is a 16-bit register. It is formed by combining DPH and DPL to 8-bit registers. So it is used to access external and internal code memory as well as the external data memory. So the program counter is clocked by this PC incrementer for every state of the system clock, which is 1/12 of the oscillator clock. So the program counter generates the address which is stored in this program address register to read the value of the program code from the ROM location at that address. And you can also see this bus is also connected to the port 0 and port 2 to generate the addresses on the port 0 and port 2 pins in case if external memory is connected and if external memory addressing is enabled. Then coming to the ports, so for every port there is a port latch and then there is a port drivers. So port drivers are used to read and write drive the pins. So reading port pins will directly read the port driver values, and you can also read the port latches. Okay. And at the bottom you have the port 1 and port 3 and this corresponding drivers. And port 3 you can see this arrow which is connected to the peripheral registers, because these peripherals are multiplexed with the port 3 pins. For example, PCON, SCON are used for UART as well as UART. Then there is a timer registers which are used for timer 0, timer 1 and timer 2. And you have interrupt enable and interrupt priority registers, SBuffer for capturing this serial data register. So these are the registers that controls this port 3 drivers in case the alternate function is used. Okay. And you have a stack pointer also connected to this internal database. So through this it accesses the RAM. So the stack is actually maintained within the RAM area itself. So when I actually build a program or compile a program for this controller, so the stack is actually needs to be set, or the stack top needs to be set to the free area after the global region, or there is a register space, 4 banks of registers. Then comes your global RAM area. Then you have to set the stack pointer on top of that. We can see this in detail in other videos of mine when I explain how to program and how to use this controller. Okay. And then yeah, that's it on the functional block diagram. Let's go through some special function registers. Just an overview, that's it. Okay, so SFR space is in the same address space as the RAM, but the upper half, that is from 80 to FF, that's where the SFRs will be. So these SFRs are all direct addressable, so it's not indirect addressable. And in 8052 architecture, you have a 256 bytes of RAM. So in that case, the upper half of the RAM, that is from 80 address to FF, that RAM region will be in parallel with this SFR space. So if you do direct addressing in that address range, that is from 80x to FFX, it will actually access SFRs. and if you do indirect addressing, it will actually access the RAM region, upper half of the RAM region. So that's the difference of the logic. Okay, so we have so they have classified it as bit addressable and non-bit addressable. Okay, so we have B register, accumulator, we have program status word. There is a timer 2 registers. Okay. IP, we have P3, we have IE, we have P2, SCON, SBUF. So you have to read address something like this. So it starts from F8 and ends at FF, like that. So if TCON is D8 means C8 means C9 is not used. Then CA is capture register for timer 2, lower, and then capture register for timer 2 up, higher, and so on, something. So that's how we need to read these sheets. So P2 we have SCON, P1 TCON, P0, and so on. Okay, that's all for today's presentation. I will make some more videos to dive deep into this microcontroller. So like going into instruction set, different addressing modes, and going through each and every peripheral and how to configure them and how to use them. So look for my other videos, and if you like this video, please subscribe and like. Thank you very much.